Welcome to the Barcelona Knowledge Hub, the Southern European and Mediterranean hub of the Academia Europaea. Academia Europaea was founded in 1988 as an international, non-governmental association of scientists and scholars from all disciplines. It aims to promote research, learning and education in all areas of knowledge. Now, it has a thriving membership of more than 5,000 scholars and scientists, amongst them more than 80 Nobel laureates. Academia Europaea has a network of regional knowledge hubs to decentralize activities. The Barcelona Knowledge Hub started at 2013. Its main goal is to promote scientific dissemination and build on excellence in scholarship, with special emphasis on transversal perspectives of the natural and exact sciences, social sciences, and humanities. Its vision is to turn science into shared common value among all citizens and to become a hub of thought and dialogue on global challenges facing humanity. To fulfill its mission and vision, the Barcelona Knowledge Hub carries out activities such as Frontiers, scientific dialogues held in English at a high academic level. Agora, dialogues for a wide local audience in Catalan or Spanish. Disputatio of Barcelona, an annual academic debate held between two renowned experts. The Barcelona Hypatia European Science Prize, awarded in collaboration with the Barcelona City Council. Exploration and development of synergies between science and art. Outreach activities to enhance visibility of the research ecosystem of Catalonia. The Barcelona Knowledge Hub will continue to encourage achievement of the highest possible standards in scholarship, research, and education.
Shift in our climate is expected to lead to major displacement of millions of people. There are areas in the world that are especially vulnerable to high temperatures, also disastrous weather events, and sea level rise. And these could all lead to these areas to become uninhabitable in the not so distant future. So climate change will bring massive displacement and permanent displacement of people. And for example, a recent estimation by the United Nations pointed out that by 2030 we could have 700 million migrants due to water stress only. And the recent trend is also that people that are internally displaced for climate reasons also started to cross borders more often due to food insecurity. So these all have major consequences for health, for livelihood, but also for internal and international conflict. And some of the areas that are mostly at risk near Europe are the north of Africa and the Middle East. And the Arab world has already experienced severe water shortages. So all of these just means that the time for strategies to prevent emergent diseases and migration due to climate change is now. And I think such strategies should also include the aspect of cultural differences. So with this, I would like to turn the floor to Rachel Lowe. So Rachel is an ICREA professor and the leader of the Global Health Resilience Research Group at the Barcelona Supercomputing Center. She conducts research that is focused on the development of methodological solutions and strategies for preparedness, response to climate-sensitive disease outbreaks. Rachel holds a PhD in mathematics from the University of Exeter in the UK, where her thesis was devoted to the spatio-temporal modeling of dengue outbreaks in Brazil. Later, her work was on the interface of climate prediction and public health decision-making, and her research was devoted to the integration of seasonal climate forecasts into early warning systems for climate-sensitive diseases in Latin America, Southeast Asia, and the Caribbean. She is also the director of the Lancet Countdown in Europe, which is a transdisciplinary initiative to follow progress on health and climate change. So, Rachel, the floor is yours.
Thank you very much. Can you hear me? Thank you, Desislava, for the introduction. It's a pleasure to be here with you all. I will just see if this is going to work. Yes, perfect. So it's a pleasure to be here today to share some of the work that we have been doing to understand how climate change is impacting our health and particularly on the risk of emerging infectious diseases. So we can see here a graphic showing the daily global surface air temperature anomaly last year in 2023, which is highlighted in red, and all the other curves are showing the temperatures from the 1940s through to the last decade. And we can see that we've just had this continuous warming with record-breaking temperatures happening year on year. And this is having a severe impact on our health. We're seeing more temperature-related mortality, more food and water insecurity, and an expansion of the transmission zone of several infectious diseases. If we take the example of dengue fever, this is a disease transmitted by the Aedes mosquitoes. And in the 1970s, there were around 9 countries reporting outbreaks of dengue. And that number has now increased to over 120, including outbreaks which have been reported in Europe. The World Health Organization estimates that around half the world's population are at risk of mosquito-borne diseases, and this is gradually increasing. Last year, we published the latest version of the Lancet Countdown report, which is a global collaboration of over 300 authors across the globe. My team is responsible for the malaria indicator within that report, and this is from an article that was published by Nature focusing in on some of the specific indicators. And we can see here the areas of the globe which have recently become climatically suitable for the transmission of the 2 most important malaria parasites. And A couple of years ago, my team from the London School of Hygiene and Tropical Medicine published an article projecting changes in the risk of the transmission of the two most important vector-borne diseases, malaria and dengue, showing that if we're to continue on this business as usual trajectory with warming of up to 3.7 degrees by the end of the century, we could see an additional 4.7 billion people living in areas at risk of these diseases, where if concerted action were to be taken to keep temperatures below 1 degree C, that number would be dramatically reduced. However, we're already way off track of staying below this 1 degree level, and we're at risk of exceeding the 1.5 degree level, which is considered unsafe for human health. So we know that infectious diseases is not just related to climate and climate change, it's also related to the way that we move around the planet, both humans and vectors, through to the large volumes of international travel and trade, which allows humans and vectors to carry viruses and pathogens around the world and introduce them to new places. If we take the example of Barcelona, the Aedes albopictus mosquito was introduced into in Sant Cugat nearby in 2004 and has since been spreading throughout Spain and across much of Europe. And climate change is also leading to more unpredictable and extreme weather events, which can also impact the timing and intensity of infectious diseases. If we take the example of Europe, a few of us, including John Palmer here, working with our partners in Greece, it was observed, adult Aedes albopictus mosquito were observed over winter for the first time in Greece. And this seems very much related to, with exceptionally warm temperatures that were observed in over the winter period of 2022 to 23. And this year it's even more sightings of the mosquito. So this is really presenting more of a challenge to vector control teams as they're having to change their schedules outside of the usual expected time for mosquito activity. We recently published a scoping review documenting outbreaks of climate-sensitive infectious diseases in the aftermath of extreme events, and we found a fair bit of evidence documenting outbreaks of cholera and diarrheal disease, particularly related to cyclones and flooding. There's less evidence related to how extremes impact dengue, although we are seeing more and more evidence, particularly from our group, on the impacts of drought on dengue. And this is partly due to the way that people are forced to store water to try and mitigate the impacts of drought. And this is having the unintended consequence of providing additional mosquito breeding sites, which can then change the risk of outbreaks just ahead of those optimum climatic conditions for transmission. We recently published a study looking at the changing distribution of dengue across Vietnam, which has a large latitudinal gradient. And we're seeing that dengue is increasing more and more into the north of the country, into the highland areas, and we're seeing a change in seasonality. And these changing climate patterns are also interacting with the underlying urban infrastructure in terms of people's access to piped water and how much they need to rely on water storage. So I'm currently based at the Barcelona Supercomputing Centre. So thanks to the ECREA professorship, I was able to establish the Global Health Resilience Group in the Earth Sciences Department. And we're an interdisciplinary group of scientists working to co-create policy-relevant decision support tools with partners across the globe to try and translate all the information that is available to us from satellites, from climatic translate them into useful and actionable information that can be used by decision makers on the ground, particularly to target interventions such as mosquito control. So we're working across different spatial domains from global to local and tracking the impacts of climate change both historically, producing short-term predictions and also projections into the future. And we're also, through our ID Alert project, looking to integrate the IPCC framing of climate change in terms of hazard, exposure and vulnerability with the One Health approach to monitoring the interaction between animal, human, and environmental health. So we have contributed to several policy reports published by the European Environment Agency, the World Health Organization, and we recently contributed to the first European assessment of climate risk assessment. And just today, a new report was published by the European Environment Agency looking at the health threats due to climate and water. On Sunday evening, the second report of the Lancet Countdown in Europe was published. The director of the collaboration, the centre was founded at the Barcelona Supercomputing Centre. So we published a series of articles outlining our approach. We published our first indicator report in October 2022, outlining 33 indicators tracking progress on health and climate change across impacts, adaptation, mitigation and co-benefits, economics and finance, and political engagement. And the collaboration is growing. And this year we published an additional 9 indicators, bringing in new aspects, including changes in climatic suitability for ticks, for leishmaniasis, and a series of other indicators. So please do have a look at our latest report. We've also been considering how we can address and try and understand the unequal impacts of climate change on health, and how these indicators can help uncover the inequalities and injustices related to how climate change impacts our health. So how do we go about creating these indicators? So we use a series of different products. These are examples of some data sets that are available from the Copernicus Climate Data Store, for example, to measure hourly changes in temperature, precipitation. We also look at different levels to do with topography. And then we integrate this with different indicators to understand population exposure and vulnerability, to help us then track how climate is impacting different health outcomes, from climate-sensitive infectious diseases to food insecurity to heat-related mortality. But these products are limited, particularly when we're trying to look at specific areas such as small island developing states. Here we can see how these products map out on different islands. So on the left here we can see the Dominican Republic, which is a relatively large island in the Caribbean. And so this particular product here, the ERA5 land reanalysis, it has a 9 kilometre square resolution, and it can pick up some of the changes. For example, we can detect the highlands in the middle of the country here. Whereas if we're looking at the really smaller islands such as Barbados, Grenada and St. Lucia, then these global products can't really tell us much about the local changes in temperature, and we need to turn to local ground truth monitoring. We conducted a study to understand how the choice of climate product can affect the outcome of a model trying to understand the change, the impact of climate on different health outcomes. So here we can see an example of a model to understand the risk of dengue and malaria in southern coastal Ecuador. And we can see the results organized by the different climate products that we've used. And if we inform a dengue impact model with meteorological station data, where local transmission is happening, we can see that a 1 temperature, if this works, would result in a 68% increase in the relative risk of dengue. Whereas if we were to use one of the global products, then it would only estimate a 40% increase. Whereas for malaria, some products indicated a negative association between precipitation and malaria, whereas some other products indicated an increase. So this work was really a sort of a word of caution to the community wanting to understand how climate impacts our health, that we can't just take these products off the shelf. So to address this problem, we have a Wellcome Trust funded project called Harmonise, where we're working to bring together multi-source, multi-scale data sets from satellites and climatic products. And we're also collecting ground truth data using drones and weather stations in particular climate change hotspots in Latin America and the Caribbean. and bringing this together with socioeconomic and demographic indicators and disease surveillance data. So we're working with partners in Brazil, Peru, the Dominican Republic and Colombia, and focusing on specific hotspot areas, for example, in the highlands, in the small islands, and in the Amazon rainforest. So our group has particular experience in co-developing early warning systems for dengue. So we published our first work in this area around 10 years ago, looking at producing a dengue outlook for the Ministry of Health in Brazil ahead of the 2014 World Cup. And since then, we've been innovating our modelling approaches and applying this work to different areas, including in Ecuador, in Barbados, in Vietnam. And we combine several different data layers within Bayesian statistical models, and then we use forecasts of the climate to help us predict what might happen from, say, 1 to 6 months in advance. And then we convert this probabilistic information into indicators that can help decision makers prioritize which areas are most at risk. So we've published a series of different papers understanding how El Nino, as Desislava mentioned, and the extreme events which are can be exacerbated from El Nino, how they can affect infectious diseases such as dengue and also leptospirosis, which is a zoonotic disease which can be transmitted to humans via contact with the urine of infected animals such as rats. So this is an example of the study that we developed with the Ministry of Health and Wellness in Barbados. So we wanted to understand how both extreme rainfall but also drought might impact outbreaks of dengue. So we compiled a database of dengue cases reported over a 15-year period, and we compared this to an indicator, the standardized precipitation indicator, which measures extremely wet and dry conditions. So green indicates the wet conditions and brown the dry conditions. And this is very much tied to El Nino events. So when we have El Nino events, it impacts the climate across the globe in different ways. So in Barbados, we tend to see exceptionally dry conditions during these El Nino events. And this has implications for dengue transmission in terms of additional breeding sites. So by combining all this information into a modelling framework to understand the delayed and non-linear impacts, we found that the increase of dengue increases immediately after exceptionally wet conditions and warm conditions, which is what we expected from the literature. But we also found this additional feature of increased risk several months after drought events. And this finding has also been confirmed in other areas, including Vietnam, Brazil, and Colombia. And we wanted to understand how this model would have done predicting the risk historically. So we compared the predictions from our model with the occurrence of outbreaks actually happening. So here where we see the deep shades of purple, that is showing that our model suggested a high probability of a dengue outbreak given this combination of climatic conditions, and the crosses mark whether an outbreak actually occurred. And we've been working with our partners in the region, the Caribbean Public Health Agency, the Pan American Health Organization, and the Caribbean Institute for Meteorology and Hydrology to use this kind of findings to inform the Climatic Health Bulletin, which is published on a quarterly basis. And they've been drawing upon these findings to produce the guidelines. And we're currently working to implement a routine early warning system on their service, which I will speak about in a moment. So this finding of the impact of drought on dengue was confirmed in this small island setting, and we want to understand how this might play out in a large, diverse geographical area. We can see here, this is an image of one of the largest favelas in the city of Rio de Janeiro. We can see here all these blue patches are the water storage containers, which are relied upon in times of water shortage. And these kind of conditions really provide the perfect storm for explosive dengue outbreaks when all the sort of climatic, socioeconomic and immunity conditions are correct. So following a similar approach, but across a large area, we modelled the impact of both drought and extremely wet conditions. On dengue, here we can see over 13 million cases of dengue across the whole of Brazil. In this image, they're organized by states across Brazil, bearing in mind that this year Brazil has seen 3 million cases just in a single year. It's experiencing one of the worst outbreaks at the moment. And we found this very similar pattern where several months after drought events, we see an increased risk of dengue. And we also found that this effect was exacerbated in more urban areas, which also coincided in areas which were reporting more water shortages. So we're currently, through our different projects, building a early warning system, which we're calling the El Niño-driven disease forecasting system. And with our partners across the region, we've been following the El Niño event that has been developing since 2023 into this year, and how it is impacting the climate in these particular areas, and using it to produce dengue forecasts from 1 to 6 months in advance. Here we can see, this is Colombia, and we can see the areas which have either low, high or medium risk. We're going to be launching this platform in the next month with our partners. We've also recently published a chapter in a book on planetary health and vector-borne diseases, outlining the different aspects ranging from sort of the co-creation process, from engagement to the development of the methods and the challenges related to the implementation of these systems. Because although we're seeing more and more tools that are available to address these problems, unless we have strong anticipatory action protocols in place, then this information won't be taken up and used. So we're really finding that there's a lack of the strong partnerships that are needed from many different sectors at the local level to be able to implement this kind of work. And this is something that we're really focusing on in the Global Health Resilience Group. And if you'd like to hear more about our research, the Royal Society made a short video a couple of years ago now, which also included some work with John. So I invite you to take a look at that, and we're producing some more videos at the moment through our different projects as well. And so I thank you very much, and I look forward to the debate.
Thank you. Our second speaker today is John Palmer. He is an associate professor at the Department of Political and Social Sciences at Universitat Pompeu Fabra. He conducts research on human mobility, inequality, and health through the perspective of ecology, demography, and law. He holds a bachelor degree of science in ecology from Cornell University in the USA, and also a law degree from the same university. He did a PhD on demography in Princeton University. And apart from his research, he has managed refugee relief projects in Bosnia, Albania, and Kosovo. And he has served as a protection officer for the United Nations High Commission for Refugees as well in Kosovo and Montenegro. Okay, so today he will be speaking about humans and mosquitoes in a warming world.
Thank you. Thank you very much.
I think so.
So it's a huge honor and pleasure to have the opportunity to speak with you. Thank you so much for inviting me and participate here. And also together with Rachel. I'm going to focus now on. And now? Much better. Speak more softly now. So thank you so much. I'm going to focus on the mosquito question and the human question in more detail, and that will include the migration topic that we have as the start. But as I'll explain, I think migration is actually not quite the issue that we need to be worried about. It's mobility more broadly, and in fact, it's aspects of human mobility that are not actually traditional migration in the sense of changes of residence and changes of residence, particularly across international boundaries. In many ways, It's a question of forced immobility combined with displacement that's most problematic and that we're seeing on a daily basis right now. The photograph I have here is of Gaza, and I think more and more, not only is this just a basic issue that we need to be focused on if we care about public health, but this is actually at the core of our understanding, or it should be at the core of our understanding of the confluence of climate change and public health and human mobility. So to start with just a little bit of background on the mosquito side, so picking up from what Rachel was discussing, to understand the relevance and importance of human-mosquito interactions, we need to understand the disease transmission process and a little bit about the mosquito life cycle. So Rachel mentioned breeding sites. This is key in understanding mosquito control and mosquito spreading because mosquitoes have this aquatic stage in their life cycle where they need water. They lay their eggs in or near water, and their larvae develop in water and then hatch into the adult mosquitoes. So water is at the core of our understanding of mosquito-borne disease. And then the actual transmission process itself involves mosquitoes interacting directly with humans by biting them and having a pathogen passed from the human to the mosquito, from the mosquito to the human, followed by some incubation period during which, if that is a virus, it's replicating and at a certain point can be passed again back to the other side of what's a bipartite network, if you're interested in network science. And that's actually the network through which these diseases pass. So our understanding of mosquitoes comes a lot from traditional mosquito surveillance techniques, and that involves public health agencies, mosquito control experts going around cities like Barcelona and placing traps like the ones pictured here. On the bottom left, you have an adult mosquito trap, which is a nice place that mosquitoes see as a cool, safe spot to rest, and they fly in and they get caught in a little bag. On the top right, you see an ovi trap where mosquitoes lay their eggs on this popsicle stick, and we can go around and count the eggs. These have, for many years, been our main tools for understanding mosquitoes, for understanding how they're spreading, also for understanding mosquito population densities in the small types of spaces like urban environments where we need to make decisions about control, where public health agencies need to decide where to allocate resources, where to go and place larvicide, where to take other measures in order to reduce the risk of mosquito-borne disease. Increasingly, though, we're finding that new tools help us a lot. One of the problems with the traditional tools is that they tend to be very difficult to scale up. They're labor intensive. They require people going out and setting and checking these traps. One of the things with several colleagues here in Spain at the Spanish National Research Council, Frederic Bartomeus, Aitana Oltra, and several other colleagues there at the Center for Advanced Studies in Blanes. 10 years ago now, we started thinking that there might be other solutions, particularly as funding was running out for getting data from these traditional methods. And the one that came to mind was letting the information that people have everywhere about mosquitoes, letting that be more useful, right? Facilitating this process by which ordinary people can actually report and provide relevant information from a scientific and public health perspective about the mosquitoes that are coming to them, right? So rather than having entomologists chasing mosquitoes around the city, simply find ways for people to report when mosquitoes come to them. And that's, in a way, that's just a continuation or an expansion of the methods that we've had for years of learning about mosquitoes. When the tiger mosquito was first detected in Sant Cugat here in 2004, that was because people living in Sant Cugat started complaining to the public health agency that there was this new mosquito biting them, right? So ultimately that information was coming from people. And so our idea by creating this digital citizen science system was to facilitate that process, make it faster, and make sure that the information was relevant for public health actors. So Mosquito Alert is the system that we created here. It started in Barcelona, it actually started in Blanes. It involves a mobile phone application, but it involves much more than that because that application connects ordinary people to this wider network of entomologists who can look at the information they send about mosquitoes, to scientists who can model the information, and to public health actors, and in this case, particularly to the Public Health Agency of Barcelona, which has been instrumental in this, and has used it to make its decisions and feed information back to the public. Increasingly, so this has been growing over time. Increasingly, what we're finding is that to continue scaling this up, and we've scaled it now from Barcelona to Spain to Europe and now beyond, Increasingly, we're finding that AI is a useful approach, because one of the things that makes the system useful is that the photographs that people send of the mosquitoes that bite them are actually validated by entomologists. But of course, that validation step requires some human intervention, and that's becoming a bottleneck as the quantity of photographs increases. So more and more, we've incorporated an AI image recognition systems into this in order to make it more efficient and make it possible to continue scaling globally. Another novel surveillance tool that we're using are Internet of Things AI-driven smart traps. The ones pictured here were developed by a startup in Barcelona called Iridian, and we've been working with them for several years now, using data that comes from 5 traps that they have placed around Barcelona that are managed also by the Public Health Agency, but that feed directly into a system that we've created that combines that data with the citizen science data that we have, and also with some of the traditional surveillance data, in order to provide high-resolution estimates of the mosquito population of Barcelona, and thus of the risk of human-mosquito interaction and the risk of disease spreading should we have an outbreak of one of the diseases Rachel talked about. The human mobility aspect, one of the things that these tools allow us to better understand is the role that human mobility plays in actually spreading mosquitoes. Right? We tend to think about human mobility in terms of spreading of diseases. It actually turns out that the process by which mosquitoes that can transmit diseases expand their ranges is heavily dependent on human movement. It's dependent particularly on the shipping of goods around the world in shipping containers, where mosquitoes tend to lay their eggs. And so at the global scale, one of the main mechanisms for the spread of the tiger mosquito that Rachel talked about, Aedes albopictus, has been exactly that. And then at medium scales, in trucks and trains and shipping containers, and in used tires, which is the theory for how the tiger mosquito arrived in San Cugat originally. And then at even smaller scales, it seems that we're actually transporting mosquitoes in our own cars. That had been a theory that people had been talking about for years. And a number of years ago, we actually went out with several entomologists and tested this by vacuuming people's cars. What the entomologists in the yellow jackets are holding are entomological aspirators, and they went and at routine traffic stops as well as car inspection stations, they went and vacuumed people's cars to see if we could find mosquitoes. In fact, they did. They found tiger mosquitoes in a number of cars, confirming that this is in fact a mechanism for spreading at small and medium scales. Combined with the other data that we have, that has actually allowed us to make estimates of the somewhat general estimates, but estimates nonetheless, of the spreading process of the volume of mosquitoes that are potentially spreading from municipality to municipality or from province to province around Spain, and thereby be able to understand kind of which are the key points to be worried about, where if you would have a big introduction of tiger mosquitoes, that could then fan out into other areas. So in that sense, what I said before is mobility is the issue. Migration for spreading mosquitoes clearly is not the issue. And that's simply a matter of the volume of people moving, right? And that's the same reason that migration is not really the issue for the spreading of diseases either. If you think about the volume of people moving globally, the number of people actually changing residence, right? Traditional migration is nothing compared to the number of people moving temporarily, right? Temporary trips, that type of mobility, that's what's key for both of these things. And in the case of mosquito spreading, of course, you need some actual vehicle or container in which mosquitoes can be moving. All of that has led to an expansion of the ranges of the vector mosquitoes that we care about. And that's the combination of this spreading process driven by mobility and the climate change process that Rachel talked about, which is making more and more habitats suitable for these mosquitoes, right? So one thing is the mosquitoes are actually able to reach parts of Europe, parts of other places in the world. The other part of it, of course, is that those places which previously might not have been hospitable suddenly are. Suddenly they have habitat where those mosquitoes can thrive. This is a map that we've generated from Mosquito Alert that combines data from the ECDC with our own data from ordinary people reporting mosquitoes to provide a real-time updated map of, in this case, it's the presence, establishment and introduction of Aedes albopictus. We have several other maps that you can see for other vector species that we focus on. Several years ago, we did a study of how well citizen science performs compared to traditional methods in being able to detect and understand that spreading process. And what we found was, and this continues to be the case, and the study was from 2017, but year after year, we find municipalities where the presence of tiger mosquitoes or the presence of other vectors is first identified by citizen scientists through our system. And in some cases, it's later also identified by traditional surveillance. In other cases, it's not. One of the interesting factors about how that process works is that the municipalities where we tend to do best with identifying first the presence of a vector mosquito are the ones farthest from the known range, right? Because to traditional methods, since you have limited resources, you tend to place these traps along the boundary of the range that you already know that the species exists in. But tiger mosquitoes tend to have this jumpy spreading pattern, and that jumpy pattern is almost certainly driven directly by the fact that it's actually passive transport in human vehicles that's moving them. It's not just this diffusive process. And so citizen science has actually proved quite key in making those detections possible. We also detected Aedes japonicus, which is another species in the same genus, which is a potential disease vector through the system and by citizen scientists. As a result, mosquito alert is now officially part of the Spanish Ministry of Health's national strategy for vector control, and it's increasingly being used throughout Spain as a way of detecting the movement of mosquitoes. Another aspect that you need to understand is also more along the human side in that network that I talked about before. What can we understand and what should we be focused on when it comes to human mosquito biting networks that the diseases are moving through? This is something that a number of colleagues and I have been focused on for a number of years, using both citizen science data, where we can ask people to tell us about how many bites they have, and also using data from molecular biology, where we can take mosquitoes, like the one pictured here, which has blood in it, and we can analyze that blood. And of course, that's human blood, which means that we can learn something about the people who that mosquito bit. And most importantly, from our perspective, from a network question, is how many different people did that mosquito bite, right? Because if we want to understand something about the movement of a disease through this network, what we really want to know about is something about the topology of the network. And one of the key questions there is the degree distribution, right? How many different people does each mosquito bite, and how many different mosquitoes bite each person, right? That has huge effects on the outcomes that we care about in terms of actual disease. So what do we expect should be shaping this? Obviously biology, right? Everybody talks about different people tend to get bitten more or less based on sort of intrinsic biochemical factors, things like that. But behavior is absolutely key. Behavior includes what people wear, essentially how much exposed skin there is in a given place where there are vector mosquitoes at the time of day when they're active. So that's a matter of clothing, and it's also, of course, a matter of spatial behavior, how people move around, when they go to work, how they get to work, all of these factors. Combined then with the mosquito populations. What are the factors that make mosquitoes particularly dense and present in a given area? So responding to this, particularly on the mosquito population side, requires in cities finding ways to treat or modify urban infrastructure. And that's one of the things that we've been looking at in one of the projects that Rachel and I are involved in here in Barcelona, looking at how we can in fact change the way storm drains are built in a relatively simple way to avoid the accumulation of water, because in public spaces, this is the primary place that the Public Health Agency finds tiger mosquitoes here in Barcelona. And so we've actually been finishing an experiment now, looking at how effective it can be to simply change the design of these drains. And it turns out that that can be relatively effective. And the last thing that I wanted to talk about is what I see as the key point. And it may seem like an abrupt jump from how to improve mosquito control in Barcelona to what's going on in Gaza right now. But as I said in the beginning, I think it's absolutely directly connected. And it's connected in a number of ways. The first is that we're spending a lot of time and money and energy really fine-tuning mosquito control methods, right? We're coming up with all of these ways to give the Public Health Agency here the most precise information about where they can place treatments. And we're trying to do this in many countries around the world, right? We're talking now with partners in Vietnam, we're talking with partners in Bangladesh, in Brazil. And the problem that we face is that there are these massive decisions that are being taken at a totally different level that are exposing people to mosquitoes and exposing people to mosquito-borne disease, as well as many other diseases, in such extreme levels that this type of kind of very precise tuning doesn't really matter. It will matter, of course, in Barcelona. It improves things in Barcelona. But it strikes me that if we can't also find ways to reduce the huge effects and impacts the mosquito-borne diseases will have in places like Gaza, then we're not doing things right. At a very core human level, of course, I think we simply need to address this as public health professionals, as academics. We can't allow a genocide to continue, particularly when our institutions and our states are so complicit, without actually finding ways to stop it. But I think we can also learn something beyond that. I think it goes beyond this particular case, which on its own is completely overwhelming. Because what I worry about is, particularly when we talk about migration and disease, what we're seeing is not the possibility that there's going to be increased migration due to climate change. What we're seeing is the possibility that certain parts of the world are simply going to be closed off and either allowed to die or intentionally killed. And what we're seeing in Gaza is the intentional annihilation of an entire population of 2.3 million people. The figures that we have from UNRWA and from the UN Office of Coordination for Humanitarian Affairs are striking. You've probably seen them. More than 35,000 people killed so far in Gaza. 1.7 million people internally displaced. And those people are living outside, exposed to a whole range of diseases, obviously being exposed to being bombed and shot, being intentionally starved by the fact that Gaza is entirely cut off, but increasingly being at risk of disease. And the reason, again, that I bring up disease here is because ultimately that will probably be the greatest source of mortality in this population. And that's the thing that I think that people are not really wrapping their heads around. I'll give you more statistics here, but one of the key ones is there's no fully functioning hospital left, right? 24 of the hospitals in Gaza have been totally destroyed, 12 have been partially destroyed, and that's all of them. 71% of the primary health centers are no longer functional. There's already 760,000 estimated acute cases of respiratory infections, 410,000 cases of acute watery diarrhea. These are things that require normal functioning hospitals and health systems in order to be able to react to them. And I think it's very obvious what the effects are going to be in terms of mortality, in terms of people's futures, if this is not addressed. And most recently, what we're seeing is, in fact, mosquitoes are playing a big role in driving concerns about what those diseases might be. UNRWA issued this statement on the 5th of May. There's increasingly reports of mosquitoes in all of these tented areas. At that time, it was in Rafah. All these people have now, 500,000 at least, have been uprooted and pushed into another area of Gaza where they will still be living outdoors in probably worse conditions if they survive the move. And I think that this is something that actually relates very much to the core of what we're doing. This is a One Health problem, right? This is mosquitoes, it's flies, it's rats. It's this confluence of human decisions, human behavior, and the rest of the natural environment. And we need to be addressing that. So I'll end there, and I'll be happy to discuss any of this in the debate. I'd like to thank my funding sources and the projects that I'm involved in with this. So thanks.
Okay, thank you. I would like to invite Rachel and John here. And then I would like to invite the audience to ask questions if they have questions. Are there any questions? Okay, I would like to ask. Okay, yeah.
Yeah, thank you very much for the presentations. I have a question for Rachel. Very impressive what you have shown, and a little bit scaring as well. But I wonder how do you measure the impact of all your research in policy, if there is a measure?
Thank you very much. So we're currently working with the Caribbean Public Health Agency and different partners across the Caribbean to actually figure out how we're going to implement these systems and conduct a monitoring and evaluation program, because it's a big challenge when you start providing forecasts and then action changes in response to that forecast. How can you evaluate how well the system's doing? Because if there is if there's a forecast for high risk and then an outbreak doesn't occur, is that because the forecast was wrong or because there was a successful intervention? So we're finding it quite challenging to figure out how we can actually evaluate how well these systems are doing. And our partners in Barbados are, they're confident that if they get a high forecast and they take action, then that is a success. But it's very difficult to actually to measure this well. We can measure our statistical frameworks historically in a theoretical framework, but it's quite challenging to evaluate going forward. There's different approaches you could take in terms of setting up some kind of randomized control trial experiments, but that's quite difficult to do in these kind of large-scale climate-driven forecasts. It's a bit different in the storm drain setting, but it's definitely a challenge to figure it out. But in terms of the indicators we've been developing, particularly in the framework of the Lancet Countdown in Europe, there are several partners across Europe that are using that information, particularly the European Commission and the Environment Agency, and our indicators have been included in the Observatory for Climate and Health, which at least at the regional level can help detect which areas are facing the greatest risks and help to sort of guide the interventions regionally. And through our Idea Alert project, we're focusing more on sort of local interventions as well.
Are there more questions?
It's a very self-interested question. I am currently at the Bank de Sang et de Sheets, and the blood and tissues bank. We are in charge of blood collection, voluntary blood collections, etc. And we have the following problem these days. Dengue is showing up. So far, mainly in people that have just arrived from outside in some trip, but there is some sense, and that's my question, there is some sense that that it's inevitable that cases where the people that have not traveled, so internal infection begins to happen. And of course, this is a strain, a financial strain, and a work strain, because we now have to include the test of dengue in the standard test of availability of blood donations. And up to now, it was being dealt by where some case was collected. Well, we did not collect in that place. But that has become, now there are too many places, so now we have to switch to checking to adding the check of the dengue to the protocol of things that are checking for the usable blood of each donation, and that's a strain. So the question is, for my information, what's your prediction? Will dengue become usual, or there is still a possibility to contain it?
That's very good.
You want dengue or others?
Yeah. I mean, there's certainly, in Europe, sort of three of the cities most at risk of dengue are Barcelona, Rome, and Milan. So these very sort of densely populated cities that are very connected to areas where transmission is endemic. And we do see every year, at least like 300 cases or so have imported either dengue, chikungunya, or Zika in the last few years. This year it's been a particularly bad year because of the huge epidemic that's happening in the Americas. particularly in the communities arriving from Argentina. We're seeing a very large increase in imported cases from Argentina. And given the detection of, we have the mosquito tigre all over Barcelona, the season, suitable transmission season is increasing. So I do think it is a real threat here in Barcelona. We do have pretty strong surveillance systems. Both the tropical medicine unit at Hospital Clinique is very linked with the Public Health Agency, and when reported imported cases are reported to the mosquito control teams, and efforts are taken to try and eliminate mosquito breeding sites around where patients are based, but it's only a matter of time before that system might not work. So we're working through our different projects to try and develop early warning decision support tools to try and strengthen, shorten the time between testing infected patients and reporting to the clinics. It's also a political problem because several households in Spain, I believe, households are not legally obliged to let mosquito control teams enter their properties, whereas in France, legally they are obliged. So we have sort of this big sort of political, environmental and epidemiological problem that we're facing.
Thanks. Rachel, you showed, one of the interventions that you showed for vector control was fumigation. And we saw, this guy shooting. And that brings me to a discussion that I have with a friend who is developing, let's say, an insecticide-based vector control strategy. There's a startup company in Stockholm. Whereas I'm pursuing a non-insecticide-based interruption of transmission. And I was wondering if in your models there is an element or a consideration of, let's say, a trade-off between large-scale elimination of mosquitoes. What's the environmental impact on that, on populations that feed off mosquitoes, or farther down the chain? So, is there a case for a non-insecticide-based interruption of transmission strategy, or is it always going to be insecticide-based?
Yeah, it's a very good question. I mean, we've been working with partners in Singapore. So they have, despite sort of excellent sort of surveillance control programs, they still have a huge dengue problem. And they have recently introduced Wolbachia strategy, and it is making a huge difference. They've seen a real drop in dengue outbreaks since that intervention. And we are looking to see how we can use the models that we developed in Singapore, which is actually a very interesting framework because we have access to serotype specific information for dengue there, so we can model both the impacts of changing immunity and climate simultaneously. And we're looking to see, using this model, what the risk of dengue would have been with and without this Wolbachia strategy. So we can sort of see, what would have been the climatic driven impact if the intervention hadn't have taken place.
John, tell us a bit more about this citizen science. In particular, I'm curious about the sociology of it. Who is the people that answer more? It's students, it's trackers.
Yeah.
So they are systematic, or they are occasional, or do you have devotees, or they task?
Yeah, no, that's a great question. It's something we've been looking into. It's something that we know much less about than we could because we intentionally avoid collecting almost any information about the people who give us mosquito reports for privacy reasons. So we've been doing side studies on top of Mosquito Alert to try to understand more about how participation works, who participates. And we've been doing things like simply looking at the areas in which people are participating. We're actually, we've just finished a study looking in Barcelona at which neighborhoods people participate from, or which census tracts people participate from. And it's not as I think many of us originally suspected or worried, which is that it's mostly like the wealthy areas of Barcelona where we're getting participation, and therefore we're not learning about other parts of the city. It's actually somewhat the opposite. We have less participation in the wealthiest areas, and we have somewhat less participation in the poorest areas, but we have mostly, it's mostly kind of the middle and to some extent the lower income brackets in terms of census tract median income, where we actually get participation. What we know about how long people participate is mostly for not very long, like a lot of digital tools. People learn about mosquito alert, they participate a little bit and often then move on to something else. We do have some long-term participants who repeatedly give us really, really useful information. Other than that, we don't know a huge amount. We've done a little bit of surveying, but of course with our surveys, we get the people, we learn about the people who participate and who respond to a survey about it. But I would say it's unlikely that it's just students. Initially, we thought that this was going to be mostly for young people, right? We thought this app would actually be for young students and something that people would do with their classes. And it turned out, based on the experience of the feedback we get, it's a lot of adults. It's a lot of people, across all ages who actually are interested because they're bothered by mosquitoes and they want to do something about it.
Okay, I have one question for Rachel. Sorry. Okay, I would like to ask, can you tell us about some examples of operational early warning systems based on climate information and how difficult it was to reach to the operational level? So you mentioned Barbados and Colombia. Are there any others, and how difficult it was in those two to reach to the operational level?
Thanks for the question. So we've been working on a operational dengue early warning system in Vietnam, and I think that the challenge around having these systems at that sort of operational level is having the infrastructure and the funding to be able to routinely produce this information. And so, for example, this system relies on purchasing forecasts from the UK Met Office to be able to then produce that information on a routine basis. So this operational system has been very much tied to funded projects. And when the funding runs out, then the system stops. So that's a sort of really problematic area that we've seen. And often the kind of agencies or partners who are able to produce this aren't necessarily operating in sort of open access framework. So one of the
like meteorological agencies, for example,
or for example, the projects like startups or different partners who are able to develop the infrastructure to host forecasts. So one of the things we're working on is trying to develop open source tools that could be used by different agencies. Particularly, we're working with Médecins Sans Frontières and the Red Cross Climate Centre to try and develop tools that can then be integrated with already existing user platforms, so that the information can help extend the lead time that's available to provide these kind of warnings, moving from, say, nowcasting frameworks to forecasting frameworks, and to ensure that the information can be produced on a sort of routine basis and that there's appropriate training locally to be able to operate these tools without having to rely on these sort of colonial structures of research, where it's people in the global north producing all the tools for use in the south, but then there's no sort of sustainability to that.
Okay, thank you.
Thanks very much to the two speakers. I've got a very simple question, which may be obvious, but in our little town we have a stream which is often stagnant, and I see many birds afterwards flying around there and probably gorging themselves on hopefully on the mosquitoes. So the question is, what are the natural predators of mosquitoes?
So it really depends on the mosquito. The problem with the tiger mosquito, it's adapted to breed in these small bodies of water where it can avoid a lot of those natural predators that many other mosquitoes are consumed by, right? So it tends to lay its eggs in bodies of water that are small enough that they don't have fish. It tends to, based on its time of activity, to avoid predation by birds. And so it's been extremely prolific as a result.
Okay, I also have a question for John. Can you maybe expand on how can we address the exposure problem in Gaza that you talked about at the end of your presentation?
Yeah, I mean, so in the case of Gaza, I think the only way to address it is by finding a way to stop the Israeli military, to stop the state of Israel from continuing the genocide. And that requires pressuring our own states, pressuring our institutions, to stop the flow of weapons, to stop economic ties, to do whatever it can, whatever we can and whatever they can, to stop this from happening. It's not a matter of tools, it's not a matter of insights, it's a matter of simply political change. And that's also why I think it's not just an issue of Gaza, I think it's a broader issue, because there's many cases like this of kind of basic political structural problems which are creating the conditions for huge problems of disease, right? In this case, it's a massive military intervention. In other cases, it's the problem of healthcare systems, right? One of the big issues that we have with dengue, like the impact that dengue and Zika and chikungunya have, is the impact that they have on actually the economies of people, the individual economies of people who lose work, who need to be taken care of for a month or more. And that depends, how that process plays out depends on all these other aspects of social, economic, and political systems that they're in. So we can focus a lot and we can do a lot, I think, that's very useful in really, really making mosquito control more efficient. And there's clearly a lot of work to continue in that. But we need to, avoid missing out on these larger structural problems, which are going to continue to be the source of the really, really drastic and harmful outcomes that we see from mosquito-borne diseases, as well as many other things.
Okay, thank you. And one more question, maybe you mentioned this, but what is the geographical area that Mosquito Alert covers? Is it only in...
So it's available worldwide, and we have reports from almost every country of the world. Okay. Our approach to making it useful has been when there seems to be enough interest in a particular country, which tends to be that we get approached by some team of people who are either scientists or public health people, then we ask that they kind of take responsibility for implementing it in that country. Our approach has always been that it's scalable globally, but it also requires a lot of local knowledge, and that requires people, taking ownership of it. And the countries where it's been most used and most effective outside of Spain so far have been the ones where there's really, active teams: Italy, the Netherlands, Greece, Hungary, and hopefully soon Bangladesh. Those are the ones that stand out.
Great.
Thank you very much for these very interesting presentations. I would like to know, I have a question on the term of resilience, right? Which is a term which we use a lot recently. And I wonder, or I would just wanted to know from both of you what you predict, or how you see within what you very well explained, climate change and the further incredible increase of disease transmission, the need for a stronger health system, for reactions in systematic changes. And I wonder if you see any tendencies. Obviously, we see that the mosquito transmission increases incredibly. Is there any way or anything you observe in terms of how humans really adapt to this increase, or how maybe the transmitted increases might be lowering? Or in general terms, how you would define, or what is the most stressful thing, or what is the most striking thing about this idea of making us or being more resilient towards the phenomenon? Thank you.
Sure. So I guess there's many ways that you see individuals or societies acting in what seem to be resilient ways when it comes to mosquito-borne disease. And the tendency has been that places that have had exposure, not just to mosquitoes, but to mosquitoes that are vectors, such that they're actually a public health problem for a longer time, are the ones that have developed that resilience, right? We see, I think in Barcelona, we see a really high level of resilience in terms of how the public health agency functions here, how much it's kind of done over the past years since 2004 to prepare and to deal with the control aspects of tiger mosquito since it arrived. The scary part is the movement of these species into new areas that have not yet faced, not mosquitoes, because most parts of the world have some mosquito, but mosquitoes that are a public health issue. And that's where the climate change part comes in, right? Cities for which mosquitoes have always just been a nuisance that haven't had to think about how they build storm drains, how they build other parts of their infrastructure in ways to avoid creating bleeding sites. That to me is the most scary or kind of the most urgent part to address in terms of the climate change aspect.
I can just add that we're just putting together a small working group now to try and understand what we can learn from the global south to increase our resilience against emerging infectious diseases in Europe. Because there's many things that we can learn from the teams that have been operating in areas where these diseases have been sort of endemic and experiencing outbreaks for decades. There's a lot that we can learn here in terms of, the health communities knowing what kind of symptoms to look out for, to know to ask about travel history, to the methods of vector control, to understanding this sort of looking at this One Health approach, how animal, human and environmental health are all interacting. So I think there's a lot that we can learn in areas that don't have the health system training and don't have the immunity to these diseases. What can we learn from the places that have been dealing with these threats for a long time?
Okay, are there more questions?
Thanks for the presentations. I was wondering how important is international coordination. I mean, cooperation, it's clear, but coordination on this issue, or can we solve it just by particular individual actions, no? in different areas?
Yeah, no, that's a very good question. I think it's essential, the international collaboration, cooperation, and we really need a lot more work in terms of data sharing, sort of also setting up sort of like equitable data sharing agreements. And yeah, I think the experience of COVID showed how important it is to have this sort of international sharing of data to really understand, how these kind of diseases are spreading and propagating, learning from different experiences about sort of the sensitivities or the drivers of different infectious diseases. And for example, in Barcelona, there's no way we can really understand the threat and the risk of outbreaks here if we don't understand the outbreaks that are happening across the globe, when and where, and how connected is Barcelona to those places where we're seeing the epidemics. And it's challenging to get access to all the data that is needed to understand that. A lot of it is private data owned by airlines, and we really need to find sort of better mechanisms to share data and make that data available and sort of usable by different sectors and communities.
But that looks more like cooperation, right, than coordination. What I was wondering is it necessary to have a coordinated type of actions in different countries, or could we have just individual, so think about Bangladesh, think about Indonesia, think about Colombia, and have specific actions there, and that could solve the issue?
I mean, it absolutely has to be coordinated, but solutions have to be tailored for the local situation, the peculiarities of each individual setting. I don't think we can sort of develop a framework and just apply it in another place without understanding the local context. But certainly sort of that coordination of, the ways to build this resilience, I think is very important.
I also think, borders, for understanding the mosquitoes themselves, borders are actually really, really important. And there's a coordination aspect to that, right? And there are international borders for sure, but also internal borders. One of the things we see within countries is how well the mosquito does by not caring about administrative boundaries when mosquito control is mostly at the municipality level all over the world, right? And from an ecological perspective, one of the big, and we've seen this in many parts of the world, one of the big ways that mosquitoes are themselves somewhat resilient is through a concept of metapopulation stability, right? So you have lots of subpopulations of mosquitoes where there's movement between those populations. And those subpopulations could be separated by administrative borders, including international ones. If you have really good control in one of those subpopulations, but not in the others, then you have the stability of the overall population because it simply keeps mosquitoes can continually move to the spot where they're not being controlled. And there's very good historical examples of that. And I think more and more international borders are going to be really key because of this actually forced immobility question that I was pointing out, which is we have people literally camped out outside the kind of most exposed populations to mosquitoes at these border areas, right? And so if there's not coordination across borders, not in terms of continuing to stop the mobility and continuing to create these conditions where people have to live outside, but to actually deal with mosquito control in a coordinated way so that control efforts are launched simultaneously at all the subpopulations of the mosquitoes, in addition to finding ways so that people are not just being directly exposed, then it's going to continue to be a losing battle.
Okay, if there are no more questions, we can close the session now. Thank you, John. Thank you, Rachel. And thank you, all of you, for being here with us tonight.
Thanks for being here. Remember, the next dialogue will be on the 5th of June. Okay? We hope you will join us.
Hi. Very happy to meet both of you. Nice to meet you. I've been following your work, and it's very interesting. And actually,